Good morning, Math 10 students, and welcome to 7.5. We are almost finished this book. So in this chapter so far, you've learned how to solve systems of linear equations by graphing, which we found time-consuming and not always super accurate. We also just went through the method of substitution, and now we're going to be moving on to the method of elimination, okay? All right, this can be a really useful and quick method depending on what you have for your linear equations. So I will encourage you to read in your books, page 428, 430, that kind of thing. I'm just going to go over how this method works. Basically, if you know something equals something, say for example x plus y equals minus 4, if I take that away from this top part, okay, and if there happen to be the same of one of the variables, in this case it will be y, and we'll see this, you'll get down to one variable, okay? And there's some really good, we'll get into some questions later in this chapter that'll explain this a little bit better so you understand why this method works. So we'll get to that in a little bit, but I'm going to show you how to do it for now. So if I look at these two linear equations, again, we would know how to graph this right now, and we would also know how to use substitution. We would probably isolate either this y, this x, or this y because they have no coefficient. Okay, so we would find out what that is, plug it into the other equation and solve. But in this method, elimination, you can either add or subtract, okay, your two equations, and you will eliminate, hence the word elimination, one of your variables and be able to solve. So in this case, if I look at this quickly, I notice that I have the same amount of y's in each, one y, okay? So I would be able to subtract this whole equation, okay? And when I do that, I will eliminate or get rid of my y variable, and I'll show you. Now this subtraction sign applies to each term, okay? So I would say, what's 2x subtract x? X, or 1x, okay? I would say, what is y minus y? 0, right? That's why we're doing this, to get rid of 1, so we've gotten rid of that, okay? So you could write in the 0, but it really doesn't make any difference. Then I'd say, what is minus 7 minus minus 4? So we know minus and minus is adding, okay? So minus 7 plus 4 is minus 3. Oh. So just like that, we've solved that x equals minus 3. Now, the easiest way to get our other variable is to use substitution. So now that I know this, pick one of these equations, it doesn't matter which one, and solve for y. I'm going to pick the second one because you can see it's a little bit simpler to solve for y. So if I take that x plus y equals negative 4, I'm going to plug in the x. So negative 3 plus y equals negative 4. Y would equal negative 4 plus 3, so it would be negative 1. Okay, so pretty quickly, we just solved this. We found that x is negative 3, y is negative 1. Just for fun, it doesn't, you don't always have to do this, but let's go ahead and use those two equations at the beginning. We said x is negative 3. And let's just verify our answers. Okay, let's check them. And I've told you, if you want to check your answers, they need to work in both equations. So let's take that first one. 2x plus y equals negative 7. Let's put in our x as negative 3, our y as negative 1. Okay, 2 times negative 3 is negative 6, plus a negative 1. That's the same as, yeah, okay, so far, so good. My left side equals my right side. Let's go ahead and take the second equation. X plus y equals negative 4. My x was negative 3. My y is negative 1. Negative 3 minus 1. Yeah, great. So, because my x and my y satisfy both equations, okay, the left side equals the right side in both, this is the correct answer. X is negative 3 and y is negative 1. And we just used the process of elimination initially, and then we did go back and use substitution. All right, so that one is actually on page 430 if you want to look in the book. We're going to go on and we're going to do check your understanding number 1. This is on page 430. All right, it says, so you could go through the example yourself. I'm going to do the check your understanding. Solve this linear system by elimination. Okay. So it should make a little room. You may notice I have an eraser today. I had to go to the school to pick something up, so I got an eraser. So pretty exciting. 2x plus 7y, and I'm using a blue marker now that I took as well. Okay, 3x minus 2y equals negative 4. Okay, awesome. So now, we're always going to look and see if right off the bat, if we happen to have the same coefficient with a certain variable or like term. So in this case, 2 and 3, not the same. 7 and 2, not the same. Okay, so there's no easy way to right off the bat either add or subtract these to eliminate one of the variables. But what I can do, we've already learned this, that if I multiply a whole equation by a number, it is still equal, okay? So we're going to do that in order to make the same coefficient on one of our variables. I could pick either one, but in this case, I'm going to go with x, okay? And if I wanted to get 2x and 3x to be the same number, what would be an easy thing I could multiply this by and this by to get them to be the same number? Why don't we do times 3? So I'm just going to put a 3 here, and this one times 2. Why did I pick those numbers? If I multiply 2 times 3, I will get 6. If I multiply 3 times 2, I will also get 6. So by doing this, I'm going to have 6x on both of these, and then we'll be able to use elimination. So let's go ahead and do that. If, just as a side note, if I wanted to use my y variable, I could have done something similar. I could have multiplied this whole thing by 2, and I would have gotten to 14. This whole thing by 7, and I would have gotten a negative 14. Okay, so let's go ahead and do this way though. So 2 times 3, 6x. 7 times 3 is 21y. And 24 times 3 is 72. All right, so all I did is I multiplied each term by 3, okay? All right, now let's go ahead and do this same thing, multiplying by 2. 3x times 2 is 6x. Good, that's good, right? We wanted to get the same thing. Minus 2y times 2, and negative 4 times 2. Okay, so now all we've done is we've created equivalent linear equations. Okay, so this system and this system are equivalent. They're still equal, okay? So if I drew these lines on a graph and these lines, they would be the same, okay? They just look different. All right, so now we can go ahead and use our method of elimination. And what I would want to do is subtract, okay, this whole thing from this one, okay? Just as a side note, I could have also subtracted this one, but I'm just doing this one because it's below and it's just easier, but either way would work, okay? So 6x minus 6x, 0, good, that's why we did that, to get rid of one of our variables. 21 minus a minus 4, 25. 72 minus a minus 8 would be 50. Okay, so my answer in that case would be 80 over 25. You could either reduce that fraction or put it as a decimal. So 16 over 5, or the decimal is 3.2. Okay, let's see what the book did it in. Yeah, it did it in decimal. Either one would be fine, okay? So there I have my y variable. Now, to solve for my x variable, I can go back and pick either one of these equations. And I could also take these ones if I wanted, but I'm just going to go back to one of my original ones. And I'm going to use substitution now to solve for x. So, looks like it'll be a similar amount of work for me. Let's pick the second one. 3x minus 2y equals negative 4. All right, we know that y is 3.2. Okay. 2 minus this is minus 6.4. 3x equals minus 4 plus 6.4. 3x equals 2.4. X would be 2.4 divided by 3, which would be decimal 8. All right. So there we have our final answers. We have our y is equal to 3.2 and our x is equal to decimal 8. What we could do, I'm not going to do this, but I could very easily go back and substitute these numbers in our original equations, and in each equation the left side would need to equal the right side, and that would indeed work out. Okay, so there you have, this is check your understanding number 1. Now I'm just going to show you one thing quickly as well that will help you. I've shown you how you can subtract if you had two equations. Let's say you had something like this. X plus y equals 5, and then you had negative x plus 2y equals 6, okay? You can see that I have an x and a negative x here, okay? So rather than maybe multiplying this all by -1 to get it to be the same, something really neat is if you already have it set up like this, if you added, okay, these two, I'll show you this, you would eliminate the x right away. So if you happen to have variables that are the same, but the signs are different, that's no problem at all, okay? You can add them in this case. So what you would do here, you'd say x plus a minus x would be 0, okay, you don't have to write that. Then you'd say what's y plus 2y, 3y, okay, equals 11. You'd say 3y equals 11, so y would be 11 over 3. Okay, so that's just to show you if the signs are different and your variable and the coefficients are the same, you can just add them and it will also eliminate. Okay, so that's another option for you. All right, I won't continue solving that. You just go back and substitute in. All right, so that is that for today. I'm just going over that one, and I'm going to assign a couple of questions. Okay, on page 437, I want you to do number 3, 4, and 5. Okay, let me just take a quick look at that with you. 3, 4, and 5. So it says to use an elimination strategy, number 3, to solve each linear system. Okay, so again, my recommendation, take a look and see, is there one that's already the same? If so, like in 3a, you can just subtract those two linear equations. If I look at 3b, ooh, that's great. You see the b's, there's a plus b and a minus b. You can add those two linear equations. If I look at c, oh, there's a 3x and a 3x, you would subtract, right? And in D, you can see there's a -4y and another -4y. So again, you would subtract because they are the same. All right, so take a look at that. Number 3. Number 4, it says, for each linear system, write an equivalent linear system where both equations have the same x coefficients and the same y coefficients. So there would be 2 ways you can do that. And then for 5, it says solve each linear. So when you get to these questions, if you don't want to do all of them, or you think you understand this perfectly, that's fine, pick and choose. If you think you need the practice, do each part of that, okay? If you're needing any help with this, please let me know. I can send you my answer key, how I've worked out all the things, or I'm happy to do a one-on-one Zoom call with you as well. All right, that's it for today. Hope you're all doing well, and let me know if you have any questions.